Okay, this one's for people like me who don't do A-level chemistry and so still have to think really carefully every time moles crop up in a question. So here we go. I would strongly suggest that when you go into your exam, you write down the following two formulae on a back page somewhere because they're not given on your formula sheet. And the first one is that the number of molecules is equal to the number of moles times Avogadro's constant, and the second one is that the mass of a sample is the number of moles times the mass of 1 mole in grams, which is called the molar mass. These two are not given on your formula sheet. Okay, but of course another formula that's got moles in it is our gas laws formula, so that's PV equals nRT. That's got moles in as well. So this is our selection. If we've got moles cropping up, it's going to be one of these three formulae. Now first up here we can see that we've got a volume there, we've got a temperature there, and we've got a pressure here. So it is in fact going to be the gas laws formula first. Don't forget to convert the temperature to Kelvin. And so that gives us 250 moles. And next up we want to know what the mass of that is. So now we've got number of moles, which is little n, and we're after mass, which is little m, and so it is that formula there. And that is the last number that we haven't used from the top there, the molar mass of the air. That's capital M subscript capital R. So nice easy calculation there. Sorry, I should have used the unrounded value there though, so that would have been 246 unrounded. So that's going to give me 7.1 kilograms. So our question has given us the molar mass in kilograms per mole because we're not heathens like the chemists. Now the next bit, it's not focusing on moles, but I've left it in because it's like the next one we're going to do. It's where you're putting two samples of gas together, and the key to this one is to add the number of moles together to get the total number of moles. Okay, so we have just worked out, we've just seen, here's our cylinder of gas, and we've just worked out that it's got 250 moles of gas in it. The volume of the cylinder is this, the gas inside is at that pressure and that temperature. And in this question, we're now going to add in, so if I draw, I don't know, another little cylinder over here or something, we're going to add in the air from this one into that one. And so for this extra bit of gas, we know its volume, we know its temperature is the same, we know its pressure, but we don't know how many moles are in there. So the first thing we need to do is work out how many moles are in this second little cylinder, just the way we did the larger cylinder. And that comes out as 61.4 moles. So that's how many moles are in there. Now we're going to take that and we're going to squash it in here. So the number of moles is going to be those two added together. The volume's this one, the volume of this cylinder. The pressure's obviously going to go up, but we are told assume no change in temperature. So this temperature is going to stay the same. And so all we do is use the formula again. But this time we've got the total number of moles in there. So the total number of moles is going to be 250 plus 61.4, not rounding, shouldn't round this one either, times R, should I forget, times the temperature, 294, all over the volume that it's all going to be crammed into, so that's this. Oh, whoops. And that will come out as 1.5 times 10 to the 7 pascals. Okay, so then the next question in the set is another one a bit like this, so it's good to go and have a go at that one now. The next video will be on that one.